Climbing in Peak feels incredibly smooth, but the mechanic behind it is actually much simpler than you might think. Welcome to the third episode of Behind the Mechanic, where we reverse engineer popular game mechanics and recreate them from scratch in Unity. Today, we'll build a complete climbing system inspired by Peak, and by the end of this tutorial, you will have a fully functional climbing mechanic with wall detection, wall attachment, climbing movement, and smooth wall rotation. So let's get started. Let's start with an empty scene. We'll create a 3D capsule that will act as visuals for our character. It already comes with a capsule collider component. Now we create an empty game object player controller, which will be the root game object, and the capsule visual will be a child of this. We'll reset its transform. Now for the first person view, we'll create an empty game object as a child of the player controller. Let's name it camera pivot, and I'll make the camera a child of this pivot. Let's reset the camera's transforms as well. I'll name the capsule as visuals. Now we can move this camera pivot up or down to set the position of the camera with respect to the character's body. So let's create the player controller script now. Let's make it require a rigid body component. First we'll define some variables to store the player collider and the camera pivot. Then we'll define the movement properties like move speed. Let's set it to 6. Let's have a jump force with a value of 5. For the ground check, we'll have a layer mask, ground mask. Let's define properties for the mouse look, like mouse sensitivity, and max look angle, which is basically how much the player can move the mouse to look up or down. Now let's make some variables to store the rigid body component. A bool variable to check for is grounded, a vector2 variable to store the player input, a bool to store the jump input, and a float to store the pitch value of the camera rotation. Let's have an awake where we'll get the rigid body component and set some of its values like freeze rotation to true, interpolation to interpolate, and the collision detection mode to continuous. We should also lock the cursor and make it invisible when the game starts. Next, let's take the player input in the update using getAccessRaw horizontal and vertical. Since this is a rigid body which is part of the physics system, we'll be doing the movement in the fixed update. Let's create a local variable to store the velocity and set it to the velocity of the rigid body. Now if the move input is not 0, then we'll move the character by setting the rigid body's linear velocity. Let's create a function to calculate the ground movement. I'll create a local vector3 variable move and multiply the right axis of the character's transform with the horizontal component of the move input, and multiply the forward axis of the character's transform with the vertical component of the move input, and add them together to get the final movement vector. And if the vector is more than 1, we normalize it, since we just need the direction, not the magnitude. Now we just return the normalized move vector multiplied with the move speed. In the fixed update, we store the target velocity from the calculate ground movement function and set the velocities x and z values to the target velocity values. We don't modify the y value of the velocity, since that is the gravity which is already simulated by the rigid body. If the move input is 0, then we set the velocities x and z to also 0. Now we go back to Unity and add the player controller script. And as you can see, the rigid body component gets automatically added due to the required component. Let's set the reference to the collider and the camera pivot. Let's also create a ground for the character to move. I'm using the Pro Builder package here. Let's move the character up and play the game. We can move forward and backward, right and left, so the basic movement is set up. Now we'll add the ability to look around by moving the mouse. So let's go to the player controller script. I'll create a function look, and let's get the mouse horizontal and vertical movements and multiply that with the mouse sensitivity. Now when we move the mouse horizontally, we want to rotate the entire character around the y-axis. So let's rotate its transform using transform.rotate and use vector3.up multiplied with the mouse x input. For the vertical loop, we use the pitch variable that we had defined and set it to the negative of mouse y so that it's not inverse, and then clamp it to our max look angle. Now we just use that pitch value in the camera pivot's local rotation around the x-axis to rotate the camera up or down. And in the update function, just call the look function. Now let's go back to Unity and play. And now we can move as well as look around. Looking up and down rotates the camera, and looking left or right rotates the entire character. To identify the front of the character, let's just add a cube in front of the capsule and also move the camera pivot a bit upwards so that it's near the head of the character. Now when we play, we can understand the front of the character, and it rotates correctly with the mouse input, and we can look around as much as we want. Let's also add the ability to jump, so in the player controller update, we check if the player presses the space key and set the jump press to true. Let's create a jump function and use rigidbody.addForce in the upward direction, and use the jump force here and the force mode to impulse to apply the force instantly. Now in the fixed update, we check if the jump is pressed, then we call the jump function and also set the jump pressed back to false. Let's go back to Unity and play. And pressing space makes the character jump. But if we keep pressing space, that character keeps on jumping upwards. So we need to add a simple ground check. Let's go back to the player controller script and create a function called ground check. We set the check position at the bottom of the player's collider and use physics.checkSphere to check for the collider within a very small radius, and use the ground mask for the layer mask. We set the value of is grounded, and then in the fixed update, we only jump if the character is both grounded and has pressed jump. and call the ground check in the fixed update. Let's go back to Unity, set the ground mask to a ground layer that I've already created, and also set the ground mesh to the ground layer. Let's play, and now we can only jump when we are on the ground, so we can't spam the spacebar to jump higher and higher. Let's create some cubes around to fill the scene. Now the basic player controller is ready, and we can start with the fun part, which is the climbing mechanic. Let's create a script climbing controller. First, we'll add some properties for detecting a wall in front of us. So we'll create a layer mask variable, a vector3 detection offset, which is the point relative to the character from which we'll sphere cast to detect the wall. A detection radius, which will be the radius of the sphere cast. Detection distance, which is how far we'll cast. And a max climb angle so that we can define how much steep or sloping wall we can climb. Let's create some private variables to store the raycast hit, the normal from the wall, a bool variable to store if the character has the wall in front. Next, let's create a function to detect and track the wall, for which we'll be using a sphere cast. Let's name it track current wall and set the origin of the cast to transform.position plus the detection offset. Now let's do the sphere cast from the origin with the detection radius and the direction to be the character's transform.forward and pass the wall hit, detection distance and the climbable mask. If the sphere cast returns true, that means we have a wall in front. Then we calculate the wall angle using vector3.angle and pass the normal of the wall hit and the wall of vector. And if the wall angle is less than the max climb, then we set has wall to false. Now let's create gizmos in the scene using the onDraw gizmos to visually see the detection working. Let's draw a line from the origin to the detection distance, a wire sphere at the end of the line with a detection radius. Let's also draw a wire sphere at the wall hit point and a ray to see the normal from the wall. Now, instead of doing this sphere cast in the update, we'll call this from the player controller update. So let's create a public function here called tick and call the track current wall function here. Now in the player controller, let's create a variable to store the reference to the climbing controller, and in the update, call the climbing controller's tick function. Let's go back to Unity and add the climbing controller script to the player. Let's set the climbable mask to the climbable layer that I've already created. We can modify the detection offset, detection radius, detection distance, and the max climb angle in the inspector. Let's keep the default values and set the detection offset to start near the feet of the player. Also, we need to set the layer of all these cubes to the climbable layer so that we can detect them, and set the reference of the climbing controller in the player controller. Now let's play and see. When we move close enough to the wall, the red sphere gizmo turns green, indicating that we have detected climbable wall in front of us. And if you look closely, we can also see the small blue sphere, which is the hit point of the sphere cast on the wall. So the detection is working, and now we define properties for the movement on the wall. Let's have a climb speed, a climb offset, which is how far from the wall will the character be while climbing, and an attach speed, which is the speed with which the character will smoothly attach to the wall. Let's also have a wall normal smooth speed, which we'll use to smoothly set the value of the wall normal. Some private variables to store the current movement, move input, a boolean to store if the player is climbing. Now let's get the move input and the climb input as the tick function parameters. We check if the character is not already climbing, but the player has pressed the climb input, which will be the left mouse button. Then we'll try to start the climb. And for that, we create a function, try enter climb, and call that here and then return. Inside the try enter climb, we return if the has wall is false, and if true, then we set is climbing to true, and the current wall normal to the wall hits normal. Now we need to keep the player attached to the wall. So first, we check if there's actually a wall in front of us. If not, we simply return vector3.0. Otherwise, we calculate how far we are from our desired climbing distance using the wall hit distance and the climb offset. This value tells us whether we are too close or too far from the wall. We then multiply it by the negative wall normal, which points towards the wall, and the attach speed to get the velocity that smoothly keeps the player at the correct distance. Now in the tick function, we create a vector3 attach movement to store the calculated attachment velocity and set the current movement to that. We also make the current movement a public getter so that we can access that from the player controller. Now in the player controller, we pass the move input and a climb head boolean, which is true if the player holds the left mouse button in the tick function call. In the fixed update, we check if is climbing is true, and if it is, we get the velocity from the climbing controller's current movement. Otherwise, we use the ground movement. Next, we create a function called calculate climb movement to calculate the player's movement while climbing. Since we're moving on a wall instead of the ground, we first calculate the wall's upward direction by projecting the wall of vector onto the wall. This gives us a direction that always points up along the surface of the wall, regardless of its angle. For horizontal movement, we simply use the player's right direction, which always stays parallel to the wall. We then combine these two directions using the player's input, where the vertical input moves the player up and down the wall, and the horizontal input moves them left and right. If the resulting movement vector is longer than 1, we normalize it to prevent the diagonal movement from being faster. Finally, we multiply it by the climb speed to get the final climbing velocity. Now in the tick function, we store the climb movement and combine both the attachment movement and the climb movement. Also, in the track current wall, we store the wall hits normal in the current wall normal, but instead of storing it directly, we create another function, update tracked wall, and we use vector3.slurp to smoothly interpolate between the current wall normal and the target normal. This is especially useful when climbing around corners or moving across uneven surfaces, because the wall normal can change from frame to frame. By smoothing it out, the player rotates and moves much more naturally instead of snapping whenever the wall angle changes, and we call this here. One more thing we need to do before testing is that we need to disable the gravity while climbing. So let's create a public function in the player controller to toggle the gravity on or off. In the climbing controller, we store a reference to the player controller and create a function to initialize the player controller. And in the try enter climb, we call the toggle gravity and set it to false. And in the player controller, we store a reference to the climbing controller and call its initialize in the wake and pass this. Now let's go back to Unity and play. And when we approach the wall and hold the left mouse button, we get attached. And as I press W, the character moves up the wall. And we can also move left and right, so we can move around anywhere while climbing on the wall. Nice. Now in the actual game, releasing the left mouse button makes the character fall down the wall. So we'll work on that now. First, let's create a variable wall lost grace time. This determines how long the player will stay attached to the wall after it stops detecting one. Without this small grace period, the player would instantly fall when reaching the top of the wall, making it impossible to smoothly mantle onto the ledge, and a wall lost timer variable to track that. Now in the tick function, we'll check if the player has not held the climb button, then we'll be exiting from the climb. So we create an exit climb function. Here we set isClimbing to false, the current movement to vector3.0, and also enable the gravity using toggle gravity. Back in the tick, we call exit climb and return if the climb held is false. We also create a function handle lost wall to increment the wall lost timer and call it in the track current wall function when has wall is false, that is, player no longer detects the wall. And in the tick, we check if the wall lost timer is more than the grace time, and if it is, then call the same exit climb function and return. And in the update tracked wall, we reset the wall lost timer to 0. Now let's go back to Unity and play. And like before, we can climb up and down and move. And if I release the left mouse, then the character slides and falls down, just like in Peak. Now you must have noticed that if you try to move sideways while climbing and reach the edge of the wall, you fall down. This is because you no longer detect any wall in front. To fix this issue and make the player rotate to the other side of the wall, let's go to the climbing controller script and add a property for player rotate speed. Now we create a function rotate towards wall, and in here we calculate the target rotation using quaternion.lookRotation, which converts the direction into rotation. And since we want the player to face the wall while climbing, we use the opposite of the wall normal as our forward direction. And instead of snapping to that rotation, we use quaternion.slurp to smoothly rotate the player towards it, with the rotation speed controlled by our player rotate speed. Finally, we call this function in the tick. Now let's go back to Unity, and now when we try to move sideways towards the edge, we smoothly rotate towards the other side of the wall. Now if I try to look up and down, I can, but when I try looking sideways, it doesn't work since the player's forward is always rotated towards the wall. And the game Peak does something nice here. They allow the player to freely look around when climbing, and that's what we'll handle next. So let's go to the player controller script and create a property, climb look limit, to define how much we can rotate the camera horizontally during climbing. And also a variable yaw to store the camera yaw value. Then in the look function, we check if the player is not climbing. Then we rotate the entire player as usual, but if it is climbing, then we add the mouse movement in the yaw and clamp it to the climb look limit and add the yaw value where we rotate the camera pivot. So we allow the player to rotate the camera horizontally only during climbing. Let's go back to Unity and test, and as you can see, I can rotate the camera now to look around while climbing. But if I release the left mouse while looking in some other direction, the camera instantly snaps back to the forward direction, since we have set the yaw to 0 when we are not climbing. But we want to preserve that camera rotation and instead rotate the character towards that direction. To do that, let's go to the player controller and create a bool preserve camera yaw. And in the look function, if the preserve camera yaw is true, then we rotate the character's transform towards that, and then set the preserve camera yaw to false. Now to modify this bool from the climbing controller, we create a public function rotate towards camera forward, where we set it to true. Now let's go to the climbing controller and call that at the starting of the exit climb function. Let's go back to Unity and test. And now, if I climb a wall, look at some other direction and release the mouse, the character rotates towards that direction. Now I found some bugs in my code that were causing some issues, so let's fix that. In here, where we are setting the velocity to 0, is grounded needs to be true, so we add that. In the calculate ground movement, it should be move and not move input. And in the climbing controller track current wall function, we need to create a separate check for the has wall and place the update tracked wall here as we are modifying the has wall before that. Now the climbing system is almost ready. The cool thing about this is that if we go up enough and reach the top, the character automatically mantles up the wall. So we can climb any wall, move in any direction, look freely while climbing, jump from a height and start climbing, and so much. The mechanic already looks pretty fun to play around with. One last thing we'll fix is rotating only the player's visual instead of the root transform. Rotating the rigid body can cause issues on uneven wall colliders and can leave the player facing weird directions after exiting the climb. Rotating just the visuals avoids both of these problems. So let's go to the player controller, create a variable to store the visuals with a public getter, and in the rotate towards camera forward function, I'll set its local rotation to quaternion.identity. So whenever we exit a climb, the character will always be upright. And in the climbing controller, we replace the player's transform with the visual transform in the rotate towards wall and in the calculate climb movement and in the track current wall function. So all this will now use the visuals transform instead of the root transform. So I have this scene set up for testing, and don't forget to assign the player visual here and also decrease the max climb angle so that we can climb less steeper surfaces like rocks or hills. And let's play. Let's climb this rock, and as you can see, we can climb, move around, go to the top, jump from one cliff to another. We can even climb trees as I've set them to climbable. Look around, and that's it. Our climbing system is ready. Now we can go ahead and add a character mesh to our player controller, add animations and IK, and the stamina and lunge mechanic to make it look closer to peak. But we'll leave that for the next part of this episode. That's it for today's episode of Behind the Mechanic. If there's another game mechanic you'd like me to reverse engineer, leave it in the comments and I'll see you in the next one.